you ever noticed the definition of life doesn't actually define what life is? That's because nobody knows really what life is. Instead, we end up using phrases and terms to describe what life does or looks like, but we're not really answering the question about what it is. The reason this is important in understanding disease is because disease only occurs in living systems. One of the conditions of disease is to be alive. That we don't understand what living means makes it really hard to understand what disease means. In that respect, it's time to undefine life and see if we can find some inroads into thinking differently about it. Just a reminder, be sure to check out zazariproject.com to learn more about this project. Let's start with Encyclopedia Britannica's take on life. This indicates it was written by Carl Sagan. Life is essentially matter that shows certain attributes or qualities. This is a common way to approach life, and these qualities include that it's responsive to its environment, shows growth, metabolizes and transforms energy, and reproduces. So again, this describes activities that life performs. But if you were to say what is life, this tells us life is matter. And this matter happens to perform these particular activities. Description, not actually telling us what life is. Furthermore, a living system is composed of one or more living units called cells. So today it is accepted that the cell is the smallest form of life. How old is that idea? If we do an internet search, we see that it's in 1665. British scientist Robert Hooke coined the term cell. Let's go to the National Geographic Society. Here we see Robert Hooke's publication, Micrographia, which is the work that established the cell as the smallest form of life. A quick calculation shows that this is a 359-year-old idea. We still call that modern. Returning to Britannica, life is capable of transforming carbon-based and other compounds, which is metabolism. Again, we're looking at what it does. It's capable of growth and participating in reproductive acts. Life has this strange ability to create. Why can matter that is living do that? And here we are, the definitions of life. There are many of them. This one talks about life from the points of view of various biological or life sciences. It's interesting we don't consider the points of view of the living organisms themselves. The main problem is this, is that people feel that it's easy to distinguish living matter from dead matter. And perhaps in most cases that's true, but there's a lot of definitional problems with that. For example, the tardigrade. Tardigrades are tiny creatures, also called water bears, that can endure extreme conditions of a huge variety. They go into almost this state of suspended animation, or suspended hibernation, they call it here. They can persist in this state with no food or water for decades. They've survived on Earth for at least 600 million years, which have included 5 mass extinctions. They can withstand radiation from outer space, endure heat and pressure around volcanic ocean vents, and survive temperatures close to absolute zero. Evidently, they can survive being fired out of a gun at nearly 2,000 miles an hour. Somebody got very creative. The important point here is that tardigrades can enter this life-preserving state of extreme dormancy. Their metabolism drastically slows and they nearly completely dehydrate themselves. Wherever we think there are rules of life, life is breaking them. There are a lot of varieties of definitions. This one is metabolic, which focuses on the biochemical activity within organism. Then there's the physiologic, which is very common in biology books and focuses on the observed functions that living systems perform, like eating, excreting, breathing, moving, growing, etc. But the trouble is many of these properties are either present in machines that nobody's willing to call alive, or absence from organisms, such as a seed, that everybody is willing to call alive. You can try to explain it biochemically. Here we end up in problems like the virus. Is it alive or not? Nobody really knows. Genetic definitions are interesting because although it's recognized as being present in all living systems on Earth, we don't think it's living itself. It's just a big giant molecule that is functionally dead. So how's that supposed to work? A thermodynamic definition tries to explain life with physical laws, but that doesn't work very well. Although life does not disobey thermodynamic laws, those laws don't explain life either. The list goes on and on. Here they're talking about newer, more complex definitions, or actually descriptions. Here's life on Earth and how diverse it is. We're getting into the biosphere. Now we're getting into chemistry. It goes on and on. This very large entry that started with life, we still don't even know what it is. I did a meta search looking for alternative definitions of life. The first thing that came up in this Google search was National Institute of Health, What is Life? Let's check it out. This is a publication by Jaime Gomez Marquez in 2021, Molecular Biology Reports. In the abstract, the author indicates an intention to offer an alternative vision to the definition of life, taking as a starting point the traits common to all living beings. So again, we're at the same starting point as the previous definition. These systems are highly organized organic structures and are characterized by being pre-programmed, interactive, adaptive, and evolutionary. These again are describing the effects of living systems, but the one I'm most interested in is pre-programmed. What an interesting word. Who or what did the programming? He goes on to consider the problem of viruses and takes a stance that he considers them living beings. And finally, that if there were life elsewhere in the universe, it would be very similar to what we know on this planet because the laws of physics and composition of matter are universal, and because of the principle of the inexorability of life. Wow, this is complicated. I'm definitely coming back to this. But for now, we've come to a good stopping point, which includes a final look at this idea of pre-programmed. The pre-programmed notion really captured my attention because in our inability to explain what life is or really define it, we've started to move principles of technology and computer thinking onto life. We're trying to impose something we do understand onto something that we don't. We tend to think of life as having processes and nodes and edges as seen in network theory. The problem is this continues to describe life just using new terms. And unfortunately, not only are those new terms not adequately describing life, they take us further away from understanding what life is. I think this is also derailing us from understanding disease as a condition of life. The more mechanized we think nature is, the more mechanized we think life is, and the more we think that disease follows mechanistic rules. Instead, disease is a behavior, the output of adaptive systems that seem to follow guidelines but work around them. An overemphasis on the idea of physical networks really distorts our understanding of how living networks behave, or in the case of disease, perhaps misbehave. In this way, it's really time to undefine life and recognize that simple observations of what life seems to be doing isn't good enough. As for how to really undefine life, I don't know how to do that yet. It's a brand new idea. We'll have to see where it goes. Thanks for listening.